Right in the middle of the New York City skyline sits a 500-foot skyscraper with no exterior lights and absolutely no windows. To the public, 33 Thomas Street is a long lines building for a telecommunications giant. Documents leaked from the National Security Agency identify the structure as Titan Point, a top-secret mass surveillance hub. Built during the height of the Cold War, it is a self-sustaining fortress engineered to protect routing equipment from a nuclear blast. Before global communication moved online, espionage relied on physical signals. Spies communicated using shortwave radio broadcasts called number stations. Operatives decoded these audio messages using one-time pads, physical, single-use cipher lists that remain mathematically unbreakable today. As communication transitioned to digital networks, the surveillance apparatus scaled to match. Instead of targeting specific frequencies or individuals, intelligence agencies began vacuuming up millions of emails, internet searches, and phone call records every day. Eventually, simply reading intercepted data reached the limit of its utility. Intelligence agencies realized they needed a way to interact with the physical infrastructure they were monitoring, so they began writing code designed to cause mechanical failure. As our secrets moved from paper documents to interconnected networks, the agencies watching those networks changed. They transitioned from passive listeners into active attackers preparing for cyber warfare. Math-based encryption does a highly effective job of protecting digital data. To bypass it, state-sponsored hackers had to engineer sophisticated workarounds that avoided the math entirely. In 2010, researchers uncovered Stuxnet. Most malware is small, maybe 10 or 20 kilobytes. Stuxnet was a 1.2 megabyte payload armed with 4 zero-day exploits. It used stolen digital certificates. Operating systems verified these credentials, allowing the virus to bypass security protocols silently. The virus was designed to reach a network that was entirely disconnected from the internet. Stuxnet crossed this physical air gap when an outside contractor unknowingly plugged an infected USB drive into a secure industrial terminal. The code was hunting for one specific target, the controllers running the uranium enrichment centrifuges at the Natanz facility in Iran. The virus fed fake data back to the human operators, making it look like the facility was running perfectly. Stuxnet proved that malicious code could inflict kinetic, real-world destruction on infrastructure without ever having to engage with the underlying encryption. This diagram shows the mathematical foundation protecting almost every piece of digital information on Earth. Modern encryption relies on the product of two massive prime numbers. This math secures global banking networks, power grids, and your private messages. Reversing this math, identifying the original factors, would take a binary supercomputer billions of years of sequential guessing. Because the math is so difficult to reverse, the information is effectively secure. That barrier is now facing an existential threat. Hardware like Google's Project Willow uses quantum physics to process information in a way that makes standard binary logic obsolete. Traditional computers rely on bits that represent a 1 or a 0. Quantum bits, or qubits, leverage a principle called superposition. Think of a coin spinning rapidly on its edge. While in motion, it exists as both heads and tails simultaneously. By existing in multiple states at once, a quantum computer can test all possible mathematical combinations simultaneously. It takes a problem that would outlast the universe on a standard machine and resolves it in a matter of minutes. The mathematical system protecting the modern world is not just vulnerable, it is reaching its expiration date. The National Security Agency calls this impending deadline Y2Q, the year quantum computing hardware definitively breaks current encryption standards. But the threat is immediate. Intelligence agencies are currently vacuuming up massive amounts of encrypted civilian and government data and storing it in vast facilities like this one. Their strategy is to hoard the unreadable data today and wait for the quantum hardware that can retroactively reveal its contents tomorrow. These agencies are prioritizing the capacity to access information over the security of the systems holding it. They are actively preparing for a world where current encryption no longer works. Because digital privacy is failing, the most sensitive operations are returning to Cold War tradecraft. Securing a secret requires physical records, face-to-face whispers in soundproof rooms, and information kept off the network. In this transition, digital storage is becoming a temporary state. As the mathematical barriers fail, physical paper and the human mind remain the only truly secure storage methods left.